Hello, everyone. My name's Duncan White. I'm your host for today's IFSJ Leaders in Fire and Safety podcast. And I'm delighted to be joined by Alec Purdy from Quellfire. Alec, hello, my friend.
Hello, Duncan. Thank you for inviting me on.
Oh, it's always a pleasure. I think that you and I could talk for forever and a day on subjects like this that we're passionate about. Alex, tell the listener about yourself and a little bit about Quellfire, please.
Yeah, sure, not a problem. So my name's Alec Purdy. I am the technical manager at Quellfire, and Quellfire are a passive fire protection manufacturer, and they specialise in service penetrations in linear gaps mostly. And then I just work in the technical team, lead them, helping our customers understand how to use the products in the right way, and then just trying to fill in any gaps where we can with test evidence and solutions where possible.
Alex, you're a very humble man. You say you just work in the technical department. You and your team are the solution to all the problems that come in from the end user. And knowing how diligent Quellfire are and the way that the customers speak about the support they get from your team, you are paramount to the success. So we're going to look at tested versus reality today, and look at the way in which Quell Selector has been updated. Look at the way in which we are seeing some of the issues around EN 1366. So to kick off, Alec, I'm going to throw this one at you, and this will get us off and running. So where do you see the biggest gap in fire test standards, and what's actually being built on site today?
Nice, short, easy answer, I suppose. No questions. So, obviously, it will be different for different elements of passive fire protection or even active. But if we're looking at 1366 Part 3, which is service penetrations, the test standards do still have quite large gaps with what's actually happening on reality in sites today. They did get an update at the end of 2021, which greatly improved the 2009 version, but it's still way behind in the sort of reality. And you get that by simple things such as the lack of supporting construction guidance. So in the test standard, it's still very focused on flexible walls that are double skin. There's a little bit about single skin walls, but in practice, single skin walls are very popular. Floors, especially, it's primarily all about solid concrete floors, whereas sites now are using things like profile deck floors, hollow core slabs, timber floors like plastable ceilings, even CLT. So they're starting to fill those gaps, but they are still quite massive. And there are some, especially what you can write and what you can test, and actually what gets used on site. There is a big sort of gap with that. Whereas, for example, cables, that's a good one. We have a cable configuration in the test standard, and that's been designed to have a series of cables that are supposed to be worst case scenario, and there you can test that. But the field of application which applies to that cable configuration, using that in reality is sometimes a little bit difficult, because, and I use the phrase, if you give people an inch, they will take a mile. What I don't believe the test standard sort of envisaged is how many cables are going to be going in walls. So, for example, the test standard says test all these cables and it will cover a data cable. So we don't typically test data cables. Now, the difference between a data cable and a normal electrical cable is an electrical cable normally has a copper core, which is non-combustible, where a data cable is a fiber optic cable, it's usually completely combustible. So a tray or a basket completely filled with data cables, in my opinion, is going to react very differently from a cable basket full of cables, standard cables. So you kind of have to use a common sense approach. So what we do at Quellfire with the test, the R&D team, is use that, but we also try and make it as practical as possible, which is sometimes difficult, and you have to spend a lot of time discussing with your accreditation bodies to say, look, this is what we want to do. What's your thoughts? Because the guidance just isn't there. So hopefully it will improve, but the difficulty with it being a EN standard as such, even though we have obviously the BS at the start, is all of the European countries have to agree, and it does take time. prime example for that, for many people that are probably not aware, is partial penetrations. That's where you just have a penetration that goes one side of the wall, drops down, and possibly comes back out on the same side at the bottom, like a radiator or a conduit. That test standard is still not even officially released. That's part 14 in the 1366 series. And that's been in draft since before I even joined Quailfire. And I have no time frame of when that's ever going to be released. And it just takes so long because it has to have so many people, so many countries, and all that involved just to all try to agree to the same thing. So yeah, it's getting better, but there is still massive gaps, which is why early engagement is really important to make sure that what you're going to build or what you would like to build can be covered by all the aspects.
It just seems absolutely ludicrous that we are, 8 years on now from Grenfell, where we're still seeing bureaucracy dictate over public safety. And we again, there's a subject that we could talk about for hours and hours and hours. But I agree with you, my friend, that if listeners here are starting out on a project, get it from the horse's mouth first to know what you need to do to sit within the compliance, and you'll get the best advice in the world. One of the other issues, Alec, that is worth looking at it at this stage is transferring evidence, and can you explain the anomaly about why rigid wall evidence can be applied to flexible walls, but it can't be done the other way around? That seems somewhat ironic to me.
It's a good point, because one of the big issues I find, actually, again, where people don't sort of understand, weirdly enough, sometimes in building control and even with the BSR, is there's a difference between a test report and the next stage, which can be a variety of things, a classification report, ETA, etc. So what I mean by that, and again, I'm going to focus on my test standard, the part 3, the service penetration, is there are agreed methods in that we can follow. That means we don't have to do thousands of tests. So, for example, a flexible wall, which is typically going to be either a single skin of plasterboard or a double skin of plasterboard, both sides of a metal stud. Now, testing that, which is deemed typically the most onerous of a certain construction, does then, when that evidence, that test report is sent away to an accreditation body, get designated with a field of application. So there's an interchangeability section that's been agreed. Again, going back to what I said earlier about all the countries have agreed a scope. So when we test a double skin flexible wall, there is an interchangeability section that says it can cover a variety of different things. So it can cover the wall it's tested, obviously. It can cover thicker walls. It can cover, if you test it in a certain way, both insulated and uninsulated, but you have to test the wall in a certain way. But the main one, as you asked, is rigid walls. So what the field of application says is the flexible wall can cover a rigid wall, so concrete or blockwork, that is equal or greater thickness, and it has a density of a minimum of 350 kg meters cubed. So an aerated concrete block, for example, is probably about 650, so a lot more dense. So they've done that because typically, if you were to do a test on both walls, the rigid wall would get equal or better than the flexible wall because it's less onerous. So to prevent manufacturers like Quailfire having to do multiple tests, there are methods to try and limit that with a field of application. That's why it's important when you're looking at test evidence, you're not asking for a test report, which is terminology that normally gets thrown around. You're asking for a classification. Now, not everything can be classified, so I just want to stipulate that. That's why you get an important document. So some things would have, say, a field of application report, a technical assessment, XAPS, that type of thing. But it's that report that uses that test evidence, uses rules and field of application guidance to give you a designated scope, which is important. So, yeah, that's kind of why there's things to apply. So again, going back, the reason why rigid walls couldn't be used for flexible walls is the rigid wall tends to be less onerous, so it's not equivalent. Whereas the flexible wall is typically worse. It bows and deflects during a fire test, for example, which you wouldn't get with a rigid wall. So that they allow that evidence to go one way, but not vice versa. The big problem actually with that, and going back to gaps, with the first question is, again, this is where the test standards haven't looked at reality, is tolerances. So, for example, the most common plasterboard wall that most manufacturers test is 100 mil thickness. That's, say, 2 layers of 12.5 mil board, both sides of a 50 mil stud. Now, that evidence can then be transferred to a blockwork wall that's 100 mil or thicker, which is great in practice. But what the test standards haven't taken into account is that blockwork manufacturers have allowable tolerances. So they can sell a wall that says it's 100 mil, but when you measure it on site, it's actually 95 mil or 96 mil. And there's no allowance in the test standards to give you that tolerance. So there are sites now building walls, measuring them, and because they haven't accounted for the fact that the wall manufacturer might not actually sell you a 100 mil blockwork wall, it might be 95 mil, that test evidence is then invalid. So that's again something that's come up with a gap of testing in reality, is the fact that construction products, a lot of them have a lot of tolerances that have not been sort of considered, unfortunately.
It's again, I'm sat here shaking my head and thinking to myself, we still have got different areas within the manufacturing and testing process working in their own little silo, and people like you are having to come to the aid of the end user, who are trying to do the best they can, but because the well, people who listen to me regularly will know that I'm quite often critical of code standards, testing, etc., and the fact that you can apply one for one thing, one for the other, and never the twain shall meet. But we seem to have got this arse about face in terms of the way that we're going about, and we're not taking into account the true considerations of what happens in reality. And at some point, is it going to take another Grenfell for these people to get off their asses, to get into the real world and watch what's going on with the guys and girls that are trying their best to build these buildings to the specifications that they've been given to work with? But my rant over, will move on. So we've heard a lot about the tolerances. We learned a lot about the way in which the reality and the tested differs. So from your experience, Alec, where do projects typically go wrong when selecting and applying tested details?
Yeah, a great question. I mean, I will say it's actually has improved, especially I think since possibly the last time I come on this show. But what I'm finding, and one of the big factors that have been raised in some good documentation that's coming out now, is making sure that you understand that when you're designing a building, there's lots of factors to consider. And going back to what you said there are silos. So going back to supporting construction, a prime example is that normally gets picked quite early on. So they'll look at the fire strategy and go, I only need 30 minutes, so I'll pick a single skin wall. Great. But what are you going to start putting through that single skin wall? Because not all service penetrations might have been tested. Not all dampers might have been tested. Not all fire doors might have been tested. You might not even have a linear gap seal, so on. And it starts to go down a very vicious cycle that you then have to look back. So you need to look at all of the information at an early stage to make sure what you want to build is practical for all elements. So that's something that is now improving quite heavily. I think a lot of projects now understand that. So they understand that certain floor types don't get tested for every type of penetration, or they can reroute services. And that's why early engagement has been massive. So that element is starting to actually come less and less. The bit that's now catching a lot of projects out, I suppose, and again comes back to the Building Safety Act, where people are starting to ask a lot of questions, is the smaller overlooked things. So again, focusing on service penetrations, it's those small things that have always just been, oh, we just seal it, or we'll use this misleading guidance from Approved Document B, which has always caught people out. And it's things that they don't even remember, or you can't have a penetration 200 mil from a fire door frame, for example, because they're tested to two different test standards. But then you'll see people put light switches, cables, even your fire escape signs or the fire door signs, everything that needs to be accounted. But because it's not recorded on MEP schedules or paperwork, it's just seen as a small inconvenience penetration that they just sort of run wild. And then you start seeing things like cables going through the top of the wall for the wall's deflection head. Well, that's damaging the wall. They have strict guidance about what distance from the soffit it would need to be, so you're not impacting the deflection head or the wall straps, the buildability of the wall itself, those kind of things. So again, it comes back to the practicality and giving all the trades, even the ones that don't think they're involved in fire stopping or passive fire protection, all the information that they need to know, because unfortunately everyone from the MEP, from the architect, everyone tends to have an impact on these elements, which is why the Building Safety Act was sort of brought in and reinforced, and why the golden thread was a really important thing to sort of track what has been built on a project, because otherwise it can just get out of hand. So yeah, that I would say is one of the biggest challenges now, which is why some of the documentation we're releasing is trying to help support our customers with and design teams with that information now, because we've heavily focused on sort of the standard build of work openings, service spacings, and that seems to be working well. They're understanding that the problems are becoming less and less. It's still an uphill challenge, but we're getting near to the top, hopefully. And now we're looking at those other areas. And yeah, it's improving, but we've still got a long way to go, unfortunately.
And again, we are in this position where all the players within the construction of a building aren't brought together at the same time to discuss these issues. And I you look back 40 years. Well, I'm old enough to remember it. I'm not sure about you, Alec, but you look at when a clerk of the works would oversee all of this and bring everything together. They would be the person with their finger on the pulse to ensure that before anybody even took a drill out of their bag or started to consider what they were going to do, they were questioned. They were made aware of the implications of what they were going to do. Unfortunately, we're not seeing that anymore, and this is why I, you and I could go on we could go on a magical mystery tour and pull up and do and pick a few random buildings, and I doubt that we would find any that would comply. Looking at what the evidence is showing us and the way that the standards are being applied in a pragmatic way within reality, and it just beggars belief that we are in midway through 2026 and we're still discussing the same old issues. Right. Let's go back and look at 1366 again, where, and especially where it doesn't fully account for constructions like white walls and shaft walls. So, how do technical assessments bridge that gap to ensure compliance?
Yeah, no, it's a great question. So obviously, again, as I mentioned earlier, the standards are lacking. There's still gaps, especially when it comes to support and construction in the test standard we at Quellfire use quite heavily. So again, I'm going to break it down because the answer for shaft walls would be slightly different than white walls, and I'll explain why. So the first thing, again, I suppose, is again, people need to sort of make sure that there's a lot of confusion on shaft walls. In the test standard, I would say it technically does cover it, but it doesn't. The reason why people say it wouldn't is because they don't specifically say the word shaft walls. But you've got to, again, make sure it's a long document, but you've got to read the full thing. So at the start, there is a table that says these are the wall types we recommend you fire test on. So for 30 minutes, it's a single skin wall, which is 12.5 mil, both sides of a 50 mil stud. 60 minutes is then a double skin wall, and so forth. Unfortunately, that level of walls is kind of outdated. I mean, for example, the 30-minute wall that they ask us to test would be insulated with 45 kg rock fiber, which for those listening will probably know the walls are never insulated with that type of insulation, and they're typically uninsulated because it's only 30 minutes. So we have to test methods for that. What it does say, though, however, at the start of that section, which people overlook, is that these are the walls you can use, or you can use a specific wall. The only problem then is when you're using the specific wall is the field of application that I mentioned earlier could be limited. And this is, again, where you've got to work with your accreditation body. And it's probably a dirty word now in the construction industry, but you've got to use a level of common sense approach to this. So what we do, especially with shaft walls, in the UK, the shaft walls are typically have board on both sides of the stud work. So that's classed as a double-sided wall. There are differences. So it is an asymmetrical wall, so it means it's different on both sides. So when we do our testing, we test from both directions. We then work with our accreditation body to build a field of application that is common sense and follows the sort of same rules and layout that are used for other walls. So it's not that they can't be accounted for. You've just got to make sure you do your due diligence, work with your accreditation body to make sure we get those set out. There are some differences between the wall manufacturers, how flexible walls can all be sort of intertwined. So with our testing, we don't have to specify it's a sort of BG Signac Canal wall. They have to just prove that their wall meets certain requirements such as classifications, and there is a little bit of difference with shaft walls there. So again, it's more an emphasis on the wall manufacturer to sort of showcase that their wall meets the required levels, which most of them can do. When it comes to white walls, unfortunately, again, very popular in things like data centers that are obviously up and coming because of technology advances, AI, etc. They tend to use what's known as a white wall system, or a sandwich panel, as some people will know it, which is typically metal with a core. For example, rock fiber. There are other cores that are used with a bit of metal on the outside. And again, that's not covered in the test standards. So you have to sort of work. So we work with our accreditation bodies, both the test lab and the ones that are going to do the paperwork, and sort of devised a way of what to test. So because then with that test evidence, you need to try and get the next step, which I mentioned earlier, like classification. It's not always possible to get everything classified. So where technical assessments, coming back to the question, come in play, and it's important to understand when we're talking about technical assessments, these are done by qualified third parties that typically will follow the guidance of the PFP F guidelines. Then they're very different from the old phrase EJs, which I absolutely hate, or engineered judgments. They will put together a field of application scope, very similar to the same methods that will be done in a classification. They use the test evidence, sort of well-known scientific field of application rules, and then they can develop a scope that sort of extends the field of application. So, for example, white walls, where we've done stuff with Euroclad's Firemast or Parox ASTF range, they've been able to use that evidence, work with us to give us a wide variety of applications that have meant that we've not had to go out and do thousands of tests or retests because there's been scientific approaches there. So that's been really useful. And I think the construction industry needs to sort of bear in mind that I know they like the term, we want everything to be tested, but in practical it's not possible. And without the likes of proper, well put together technical assessments, the construction industry is going to grind to a halt because of these modern forms of construction. Now, that's not to say there shouldn't be restrictions on them, rightly so, and that is going to be more done in the future. So now there is a guidance document called the PFPF guidelines, very good document, sort of explains the competency level, what sort of evidence you need, sort of impartiality, that type of thing, and even talks about insurance. That's going to be more developed in the future. It was hopefully going to be out possibly next year, but I think it's now been sort of pushed back to 2029, where that's going to be more developed into a proper standard and method. So yeah, the construction industry and the people behind the scenes that work with these standards and regulations understand the importance of this aspect, because there's just no way to physically test everything. We don't have the resources all the time, and the equipment itself is limited as well. So that there needs to be approved methods that we can follow, and they do work. So that's where we're trying to bridge those gaps with even something simple as a profile deck floor, which is still concrete, just on your metal profile deck. We've done testing and had approved ways to do that, even though technically a profile deck isn't covered in a test standard, because we've used that common sense approach with science, with fire test evidence, and we get all the relevant parties to agree to it, and that's benefited the industry quite heavily.
It's again, I've been shaking my head quite a bit through that, through your response there, especially when you're talking about the white walls, or as us seasoned people know, sandwich panels. And how many firefighters are going to be killed fighting fires in buildings constructed by sandwich panels? The fire can spread unchecked until the point of instability, and again, we've got to be getting on for 20 years since former colleagues of mine, albeit in a different fire service, have lost their life by fighting or attempted to fight fires within sandwich panel buildings, and it just beggars belief that again we've got no standards to cover that. But I think in my mind I may be inviting a guest from building standards in the future to come and sit and let me have a rant at them. But whether the powers that be will allow that to happen, we'll only wait and see. So, Alec, I'm conscious that we've been talking for some time, but there is a positive question I think that we really should get an answer for. Is so. There are projects out there that get it right. So what's typically happening behind the scenes? And I mentioned Clark the Works, but we know that they're a thing in the past. But what are these projects getting right behind the scenes so they do get it right every time?
Yeah, no. Again, great question. I like one big factor I do like is trying to talk about positive things to showcase things are getting better. So I think there's still an uphill challenge for a lot, but I think the ones that embraced, and I think I don't know if we talked about it at the start or before we talked on this, there was a lot of people that put their head in the sands and just thought that things were just going to go away. But the Building Safety Act isn't going to go away. The BSR is there. Obviously, it's improving all the time and we're getting better. But the ones that embraced that early on understood that things had to change. The way we did things need to change. And I'll be honest, there was a rush to the bottom years ago, especially with competency and products and design, that the Building Safety Act has really flagged up. There is a severe lack of skills, knowledge, and attitude with certain things of, unfortunately, going back to what you said earlier, probably a lot of buildings before probably aren't compliant. And I very much doubt they are, because the amount of meetings I've had, not so much now, but previous, where you open that can of worms of, well, that's not how we did it on the last project. And it's like, well, then you did it wrong. So it's not, that happens quite a lot, but it is improving. I think the ones that are really getting behind it, they're working together, they're doing that. The amount of times I've now been, myself or even the rest of the technical team, have been brought in at REBA stage 3, very early compared to REBA stage 5, where we used to get brought in, where really we couldn't do a lot of changes then, and we probably caused a lot of headaches for a lot of people because of the they hadn't really designed it with fire stopping in mind. It's being really done at that stage, and there's a lot more people talking to us that weren't really interested in fire stopping before. MEPs, architects, that's probably a bad thing. They were interested, but they get very little knowledge. But they're now hungry for that information that they're asking, and I think the more questions people are asking, the more people are learning, the less and less things that people used to get away with are happening. One of the other positive things is collaboration. We're realizing that a lot of people were in their own little silos, and we're now starting to breach those walls and talk to each other and work. And works both ways. I learn a lot from limitations from the wall manufacturers, from dampers, from electrical regs, gas regs. There's things that I need to be aware of that I can feed back to our research and development team, because although it might work for fire stopping, it might not work for other requirements in the building, and it's got to be a mixture of all those. So yeah, it is getting better. It's still, again, I said, an uphill battle, but I think we are getting closer and closer to that summit. And I'm hopeful that we shouldn't hopefully have another Grenfell. Obviously, I touch wood, it would never do, but like you said before, I think the accidents sometimes are the only motivation some people get, which I hopefully has changed in the industry. But yeah, there's still room for improvement. I'd say, going back to what you said earlier, just before, I'm obviously not as positive, but I do think one of the things I've learned recently from doing some demonstration with firefighters is they are overlooked sometimes, and people need to obviously realize it's not about just people coming out the building safely. It's about trying to keep a building safe when people have to go in, especially firefighters. So there are still flaws in design where they don't think about this. I'm still seeing inverted cable trays where the cables aren't secured properly on the cable trays, and they could drop down and be a tangle hazard, which did unfortunately kill firefighters in the past. You've just obviously mentioned the white walls. There are service types that go in there that can be quite lethal as well. So I think there is still a bigger picture that people need to realise, and I think they need to start realising that the Building Safety Act is there to make sure everyone gets home safely, from the residents to the firefighters, and that as well. So yeah, it's positive. We're moving in the right direction. That's the main thing so far.
And we like to take as many positives out of the bucket of negatives that we can. And one thing I think that the Building Safety Act has really hit home, and people should be waking up and smelling the coffee, is that the culpability is that you can't not know something once you know it. And when it comes down to the whole issue of corporate homicide, corporate manslaughter, whichever phrase you want to use, and the vicarious liabilities and the insurances, there is now a chain of evidence that can be scrutinized, and it will be scrutinized when something goes wrong. And we're still waiting to see the level of prosecutions that will come from Grenfell. But I have no doubt that when that happens, that will send a huge shockwave around the industry, which will have a very positive impact. But again, why should those 70 odd people that perished at Grenfell have to be the cause for things to change? But we will see change, and the Building Safety Act will assist us with that. But I agree with you wholeheartedly, my friend, where you talk about that people forget that when the majority of people are running out, the firefighters very often now have to run in to rescue those that unfortunately have been overcome. But we will keep talking like we do here. We will keep raising the awareness. And what I will say to the listener is that I've had the pleasure of speaking to one of the industry's experts in this, and I would urge that if you've got any questions, that you drop Alec an email at technical@quailfire.co.uk, and you'll get the best of attentions. And for more information on what the whole team at Quailfire do, then simply quailfire.co.uk is your handle to get there. Alec, my friend, it's been an absolute pleasure. I do enjoy seeing when my diary says I've got a conversation with you, and I'm sorry I missed you at the fire safety event, but every time I walked past, either you were busy or somebody collared me. But I'm sure that we'll catch up face to face soon.
Oh, much appreciated. Thank you.
Oh, take care, my friend. I'm Duncan White. I have been your host for today's podcast with Quailfire as part of this Leaders in Fire and Safety series. Take care, everyone.